Section 5, I can make a function table and graph it from a real world problem. Make sure you guys take out your guided notes and all your other materials that you have for every other lesson. Make sure you fill out your notes as I go through this lesson. Just a reminder, a linear function is a function whose graph is a straight line. If you look here in the word linear, you see line. So that's just a way that can help you to remember the definition. A linear function is a function whose graph is a straight line. You guys see the word line right there inside of linear? Okay, so that's just a little help to advice to help you remember that definition. Alrighty, so linear versus nonlinear. If I know that a linear function is a function whose graph is a straight line, I would ask you then to tell me which graphs here represent a linear function. Hopefully you would be able to pick out 2, 4, and 5. All three of those graphs graph a straight line. Alrighty, function tables. Back to what we did back in section 4. Just going to add in another thing to where we're going to have them more real-world situations and have you guys graph them. And then we're going to talk about independent and dependent variables in this section as well. So Jasper hikes 3 miles per hour. The function rule 3x, where x is the number of hours hiked, can be used to find the y, total miles hiked. Make a table to find out how many miles Jasper walks after walking 2, 4, and 6 hours. So all I did here is made my table, input, rule, and output. My rule here can be found right here in the problem. And I'm telling you that I want you to find out how many miles Jasper walks after walking 2, 4, and 6 hours. So my input is hours. My rule is 3x. So once I plug that in, these are my output values. And what I need to do with that is I want to go ahead and have you all graph these points in 618. I want you guys to go ahead and graph those points, make a graph. Here we go. And you can see here on the graph that I have here, you can see that I have labeled my axis. Your x-axis and your y-axis should always be labeled to show what those numbers represent. So here I know that these numbers down here, 2, 4, and 6 represent 2, 4, and 6 hours. And then these numbers right here going up represent miles. So all I did is plotted my points of 2, 6, 4, 12, and 6, 18. The next example, example 2, Isaiah is buying jelly beans. In bulk, they cost $3 per pound, and the candy dish costs $2. The function rule, 3x plus 2, where x is the number of pounds and y is the total cost of jelly beans and candy dish, make a table to show the total cost of buying 2, 3, or 4 pounds of jelly beans and 1 dish. So once again, all you have to do is plug in your values like I did here, your 2, 3, and 4 into the rule, and then it will give you your output answers. And then what I need you guys to do is probably pause this video, and I want you to graph those points on the graph and try to label what your x-axis would be and what your y-axis is representing. Everything is right there in your function table. You just have to remember that you have to label your axes. All right, now go ahead and check your answers with mine and make sure that you have the correct answers. And if you don't, make the corrections that you need so that your worksheet reflects the work on the board. Next, relationships and graphs. When looking at a graph, you can determine if there's a relationship between the x and the y coordinates. There is not always a relationship between the x and the y coordinates necessarily, but we are going to look at this one right here. The title of this graph is Band Concert Ticket Sales. So my x-axis here are the number of tickets sold, and my y-axis here represents the money collected, and that money is represented in dollars. So, like I told you, the x is the number of tickets sold, and the y is the money collected. Is there a relationship between the two? So looking at this graph, is there a relationship between the x and the y? Well, if you look at this, the more tickets sold, the more money is collected. So the number of tickets sold, the more tickets that are sold, the more money that is collected by the people who are selling the tickets, which makes perfect sense, right? The more you sell, the more money you get. The next one, this graph right here represents widgets sold. So I want you to try to figure out what the x and the y coordinates represent. Looking at this graph. Your y coordinates represent the year, and your x coordinates represent thousands in dollars. And then ask yourself, is there any relationship between the two? Do the years have anything to do with the money? Does the money have anything to do with the years? Anything like that? All right, so I would say no in this situation right here. The year has actually no relationship at all with the amount of money, the thousands of dollars in the year. So in 1993, there was about $25,000 in sales for widgets. In 1994, there was 40,000. In 1995, it was about 35,000. In 1996 was about 45,000. So there really is no direct relationship here. And another graph we have here, this is the value of Sarah's car. So as you can see here, my x and my y coordinates, my x coordinates are represented by the year, and the y coordinates are represented by the value in dollars. Okay, and if you look at this graph here, you can see that we start at about $24,000, and then we end up here at about $5,800. So in 2001, the value of Sarah's car was $24,000, and in 2007, the value of her car went all the way down to $5,800. So the relationship here would be, as the car gets older, the value goes down. The value of the car decreases. So there is a direct relationship in this graph. The next thing that we're going to talk about are independent and dependent variables. When looking at a function chart, the x value is also known as the independent variable, and the y value is known as the dependent variable. The y depends on the x value. Okay, so the independent is x, that's what is changing, and the dependent is the y, what is affected by the change. So I want you guys to identify the independent and dependent variable here. The dance committee is selling tickets to the fall ball. The more tickets that they sell increases the amount of money they can spend for decorations. So let's take a look at what are my two variables. What are the two things? The next slide I highlight here for you that the dance committee is selling tickets to the fall ball. The more tickets that they sell increases the amount of money they can spend on decorations. So notice here how I highlighted some key things. The two variables would be my ticket sales and the amount spent on decorations. So which one is dependent on the other is the question. And the amount of money spent on decorations depends on the number of tickets that are sold. So with that being said, the independent variable would be my ticket sales, and my dependent variable is the money spent on decorations. Generally, the average price of going to the movie has steadily increased over time. So I want you to identify the two variables here. And my two variables would be price and time. Movie price and time. So now, knowing my two variables, which one is my independent variable and which one is my dependent variable? Which one depends on the other? The independent variable is your time, and the dependent variable is the movie price. Okay, I want you guys to try this one on your own. Victor is working towards saving money to purchase sneakers that cost $68. He has $15 saved and will continue to save $5 each week. How many weeks will it take Victor to save enough money for the sneakers? So go ahead and pause the video and try to identify the two variables, and then tell me which one is the independent variable and which one is the dependent variable. Okay, let's check your answers. The two variables are the amount of weeks and the amount of money Victor saves. And then your independent variable is the amount of weeks Victor saves, and the dependent variable is the amount of money that Victor saves. So if that's not what you had, please make the corrections on your notes, and we will move to the next slide, which you will need to get out your green entrance slip sheet so that you guys can answer the questions on the next slide.